introduce my project. This is Alzheimer's prevention. So basically, the idea is to predict someone's diagnosis on Alzheimer's, meaning that if someone has or not Alzheimer's. And also, I will be comparing two different models. In this case, logistic regression and an ensemble method, which is random forests. So for this, I'll be walking through different steps in the project, such as loading the data and exploring it, analyzing it and cleaning it, creating the models with Python's sklearn library, defining the training and test data, 80% for training data, which is the most common practice, and train and test the results and analyze them. In the last part, I'll be showing an improvement on data based on the results that we got. So, and we will also see if that improvement leads us to an improvement on the results, right, on the performance. So here is our data source. We have a 600 kilobytes file. It's a CSV file. Here is the source. With 35 columns, 2,149 rows, 21 categorical variables, and 12 numerical variables. Our target variables is the diagnosis, which is a categorical one. It can only takes either 1 or 0, depending on if it is positive or negative, right? All the data is already mapped. We don't have, when I say map, it means that there are no strings in the categorical variables. We already have either 0 or 1s. The same for forgetfulness, disorientation, confusion, and, well, yeah, these other variables. Cholesterol total, it's a numeric one. It's an example of numerical variable here. So, yeah. Well, here we will be importing all of the functions and classes that we need from sklearn, and also numpy, pandas, pyplot from matplotlib, and seaborn. I think we are not using it. And here we are importing our data from the CSV file using pandas pandas in a data frame. So with this head method, I can just check the first 5 rows in the data set and see that we have some data that can be removed. Definitely, this is not meaningful data. So that's our next step here. Our next step is to remove these 2 columns that are essentially non-meaningful data, the patient ID, which is a numeric value here, an integer numeric value, and the doctor in charge, which is mock ID. This is totally meaningless, right? Furthermore, here I classified the data programmatically. Since I have previously mentioned, we have all the categorical values already classified as 0 or 1s. So we can just get the integer values and assume that they are categorical, and the numerical ones will be the floating point numbers, right? So as you can see here, confusion can only have 0 or 1 value, disorientation, personality changes, meaning that all of these variables are measured in a way that will be either true or positive, yes or no, right? Same for diagnosis. ADL is a numeric value, it's a floating point number 1, diet quality, physical activity. They are being measured differently. So here we will also be evaluating if we have any null values in the columns, any none columns. And luckily we don't have any none values in any column, so we can proceed here with our correlation matrix. This is the correlation matrix that I created for this exercise. Well, we can see that there are no highly correlated values. Like the highest relationship here that we have is between diagnosis and behavioral problems, and diagnosis and memory compliance. Those are like the highest ones. Here I created a split data function. So essentially we will be splitting our data with this function using train test split, the train test split function from sklearn. So now you can see that I'm using the test size will be 0.2, which is 20% of our data, and we'll be getting all of these data sets here. All of this data splitted here, right? Here I created a graphics class to get different plots, different types of plots, such as bar, pie, and this is the ROC curve. We will be displaying it below. So well, I created here this class, and here we are instantiating a graphics object from the graphics class, right? Well, here I would like to point out that I wanted to plot the distribution of our target, which is diagnosis. As you can see, it's a little bit unbalanced. I mean, it is not perfectly balanced, but I think it is okay. We have 64.6% for negative values and 35.4% for positive values. I think I can change this for target because we already have a variable target defined here at the top of our Jupyter notebook. So well, here in this step we will be creating our models, the logistic regression one and the random forest classifier one, and we will be fitting our models, right? So we run the fit for the logistic regression one and the fit for the random forest classifier one. Also, we will plotting the ROC curve for both models and getting the area under the curve for both models too. So here you can see we got like a better performance for random forest classifier. Tends to classify better the false positive values than the logistic regression one. Also, the area under the curve is higher, is greater than the logistic regression one, so that's good. That well, we can infer that the random forest classifier will behave and perform better than the logistic regression one. Well, here we will be simply predicting new data based on our X-test data that were previously split here. So as you can see, we are assigning this value for the Y-pred random forest data and for the logistic one. Here we are measuring the error with this getError function that I designed here, and we get that the error for the logistic regression is 16.98%, and for random forest is 9.07%. So it is much better for random forest. Here we are running precision and recall with this function that I created here. And also, well, we can come up with some conclusions. Before that, I want to show you these feature importances property that we have only for the random forest classes. We don't have it for logistic regression, unfortunately, but it gives us a good idea of which features were important when we were classifying everything. So here we have our top 5 features: confusion, disorientation, personality changes, forgetfulness, and difficulty on completing tasks. This will be important for the last step on this project. Here we have the reports. Essentially, based on the reports, we can conclude that precision and recall, based on the precision and recall when predicting true values, random forests in the overall tends to behave and perform much better than logistic regression, as you can see here, right? So next steps are an experimental phase to refine data set based on the feature importance variables that we computed previously. So here we will just be removing the features that have 0.01 or less than 0.01 values, right? So we will be trimming all of these features that seems to don't have like a high importance when predicting the value, our diagnosis. So I just removed those columns. We have a new data frame here. We will splitting again the data for the new data frame, creating the logistic regression model and the random forest classifier. Now we have a new curve here, new ROC curve, and well, as you can see, the values were improved. If we compare with the previous one before we removed the features, the less important features, here we will be predicting the values, measuring the error. The error were also improved for both models, for both classifiers, but the best improvement was for random forest, because it was from 9% to 5.58%. So that's a great improvement in the error. And also we saw an improvement here in the recall and the precision, in the precision values when we are predicting true values, right? Even the macro average and the weighted average in the report shows some improvement for both of them. So well, that's all what I wanted to show. We can this project could be better if maybe when we add some iterations on these feature importances, and we can keep removing features that until we have like our best performance model, we can get the best performance model. So that would be an interesting topic to work on. And yeah, that's all. Thanks for your attention.